I've been very, very excited to come here. I'm based in Detroit, Michigan, and I run a program at an institution called Cranbrook Academy of Art, which I will talk quite a bit about. And the reason I'm extra excited is because I've spent much of the last few decades with creative communities that blend creativity and technology. So my focus has always been on things that combine the physical and the digital. I worked for many years at design firms. One of them was called Smart Design. I was there for a number of years, and I sought out jobs where I would have work that involved physical things with embedded electronics, so that there was a behavior and you were kind of crafting the way that they moved or the noises that they made. And there were opportunities in other areas of design, but I had decided that this was really my focus. Somewhere in graduate school, it came to me that this physical and digital were going to come together. So I worked mostly on product design, and then what's also been very, very exciting for me is discovering new things and then sharing them. So doing things like exactly what I'm doing tonight and talking with other people about this is really just the front and center of my career. So in addition to actually having done the design work, I've been involved with a lot of talks and festivals, as well as writing projects for New York Times, Popular Science, The Atlantic, etc. The New York Times also had me do a really fun essay that was in the opinion section. And as part of that essay, we did a slideshow where I was talking about this, what I'm going to talk about a little bit later, about how we'll see robotics in our everyday lives. And this was 2012, I think. And there was a lamp that would wake you up in the morning, and a bathroom mirror that would talk to you, a bicycle that would know your directions, a pen that would email you your notes, the door that greets you, and a chef that helps you in the kitchen. And all of these things since that time have become startup companies. And so it's been, I worked with Katie Turner, who does this really lovely, playful, childlike style of drawing. And, to watch things come to life has been exciting. Another project that was one of my favorites in my own studio, when I stopped working for design firms, I was working on my own independent projects. And one of the things that I really, really wanted to do was a children's book about 3D printing. So one of the things that I've loved is anytime there's some new phenomenon in technology, in this case, it was the ubiquity of 3D printers, the idea that people would have them in the classrooms in their lives. So this book was, I think, from 2013. And it features a number of drawings as well as 3D models. And anything that's a 3D model in the book can be downloaded and 3D printed. And it was a really fun experience. I have an example of the book here. There's people all over the world then. It gave me a chance to experience this idea I was thinking about. I had experience as a designer making physical things and then having them molded and shipped and stored. And I thought, what if a person could just have it overnight? And this project allowed me to get a feeling for that. And so the objects appeared in Japan and Britain, all over the world. I'll have to check if there's some in Armenia. But people made their own stories about them, and it was a really satisfying project. And then in addition to that, I've been teaching along the way. I love this idea of being involved in both industry and academia, because industry allows you to try out ideas and have them show up in everyday life. And then academia allows you to try out ideas that are really going to be much more future expecting. And all of the stories I'm going to tell you today are ones that I've written about in my book, My Robot Gets Me: How Social Design Can Make New Products More Human. And the way all of this comes together and the things that connect them start with robots. So in part of my journeys back and forth between industry and academia, I had met in 2007 a researcher at Georgia Tech. And I'm going to take a little parenthetical statement right now and just say that everything I work on depends on communities. The reason I do things is for communities, for sharing ideas and enjoying the excitement. And what you're going to see here are projects that involve really wonderful teams of people. So in 2007, I was a visiting assistant professor at Georgia Tech, and I met a professor whose name was Dr. Andrea Tomaz, who was working in a field of robotics, a subset of robotics. It was called social robotics, that I never even knew existed. And this field involved creating physical things that you could interact with. They were computing machines. Instead of knowing code or button presses or some other interface that you had to learn, all you needed to do was what was proposed was to approach this machine with what you know as a human being. So, for example, I know how to wave to you in the back of the room. I know how to say hi. I know how to be shy. And those are the things that we had the robot do. So I was there as the physical designer, thinking about the lights, thinking about the shape. In this case, we had some body shells, but I really focused on the head. And I exaggerate the ears in a lot of my designs because that's the way that animals communicate with us non-verbally. So it was trying to ride this line between a machine and a person, and somewhere in between that's neither. So some things are exaggerated. This robot can nod its head, it can look at you, has cameras in its eyes, it has a microphone, and it learns. So this is an example from the Chi conference of the robot learning. So this was before everybody in the world was talking about AI, but these people I was able to collaborate with in Andrea Tomaz's lab were using AI to help these machines learn how to learn. So this was sorting colored objects, and the person says, take this, Simon says, sure, and then she says, what color is it? And the robot will actually make these gestures. So the robot understands gestures, it makes gestures, it will let you know if it understood something, and then it will learn. And so if it doesn't know, then you teach it. You say green, and it's able to parse the sentence and pick out the word green. And and then there are also all these amazing, so these videos are a little rough. They're just me at the conference. But what was amazing about it to me is that I had worked on this project with the team for at least a year and a half or so and knew exactly what was inside. I knew every motor that controlled those eyes. And yet when I stood in front of it, I got goosebumps, like it knew me or it knew what I was thinking. And it made me respond in this way that was pretty emotional and really intuitive. And my interest has never been in these purely these robots, they're so sophisticated. They have fingers, they have arms. And I'm interested in how can we learn from these little moments, like when the ears light up and I know that it understands I'm asking about color, it made me just feel so satisfied to know that it understood me. So I call this robot Tai Chi. It's just going through a sequence. So these have been really amazing projects. I've wound up collaborating with Dr. Tomaz for many, many years. She went on to UT Austin, went on to collaborate with another woman named Vivian Chu. We did another robot that was super stripped down, just a 3D camera on a stick, and with that one I really wanted to humanize it by giving it softness. So this one has this coat. And then what wound up happening is Dr. Tomaz was approached by the investor who understood that there would be enormous value in the hospital setting. Nurses were quitting, they're exhausted, they're running sometimes 5 miles, 10 miles up and down the hallway. And what was noticed was that if they could have some bit of help to take the physical labor out of it, that it would help them stay in their job and help them stay healthy. So what was created was a company called Diligent Robotics, and I was brought on the head of design from day one. The identity, the shape of the robot. And so we had some really great researchers who would go and talk with the hospital workers. So we understood, again, I wanted to abstract things things, not necessarily have a head, but what was really valuable for the company were these social interactions, was being able to have what we call, shared gaze, looking at something that's spilled together, being able to look at someone in the eye and know that that's where your focus of attention was, being able to navigate the hallways and be appropriate about gestures. So this is just a little bit of how the robot works. And this is a pharmacist who's putting the medication. So a nurse can stay with the patient, hold their hand while they're suffering, and ask for whatever they need, the blanket, the water, in this case, the medication, and then it will get delivered right outside the door. So this has been a really, really satisfying project that's taken many years, and it's actually shown up. This company is in Austin, and I'm in Detroit, which is actually, I don't even know how many hours away, but they're a fleet of them in the hospital that's just a mile from my home, so it's really fun. It's my son. We drive by, and he goes, "Can we go see Moxie?" And sometimes I go and just ask people and don't tell them who, that I worked on it. And I say, "Is this the hospital with the robot?" And so I'm, just to understand, because it was super new and we were really pioneering, and we don't know if that, approach is right. We certainly did deep research. So now what I talk about in the book is my ultimate goal, which is really abstraction. So it's not, again, and that Moxie robot is also super complex, sophisticated, an amazing team of engineers that I continue to love working with. The company's grown. They have a design team, so I've actually stepped back, and I'm design advisor. Once a month or so, we have a challenge. But Moxie is the name of the robot, is an extreme example of social intelligence. And what I was interested in is how can we learn from that social intelligence and apply it to everyday things like this microphone or these lights or the door or the camera. So I wrote about all of these experiences to share it with designers and to begin this dialogue. And the book starts out talking about how our products used to be containers of set messages, right? Like your microwave would beep 3 times if the plate was done. And now what we have are these products that can be entities. So they may be unscripted. It may be able to say, "Oh, your dinner party is ready. Why don't you try this?" And what does that mean? What does it mean for product designers? And how do we think about this when it requires a team, when it requires so many different parts of the process? So I came up with this framework thinking about the way that I've been working with the team that starts with this presence at the core, which is actually physical form. We tend to think, oh, electronics, now it's just a black box, it's hidden, but the form really matters, and it's my first love, is actually design, form design. And then we have expression, interaction, context, and ecosystem. So I'll talk a little bit, some examples from my own work. This was with a team that was found by a drummer, professional drummer named Conrad Meisner. It's called the Click Brick, and it's a drummer's metronome. So Conrad was complaining that the metronomes that he always used up on stage would be the little box with lots of fussy buttons. So he would be there like this, and the drummer sets the tempo for the whole band and makes eye contact with them, and then at one moment he has to do this to set the metronome. So I worked with this team, Ted Muth and Mike Glazer, in order to have a drummer's metronome. So now what he can do is he strikes it with the drumstick. He can set the tempo by striking it at the speed that he needs. He can also use this dial, and he can start it and stop it, and it all just connects to his drum kit. So that's where presence really comes into play. It's a big difference between the little fussy thing with the buttons and this thing that allows him to be a performer. Then next in our framework, we have expression. So I've always been interested in this language that our physical objects have and how we intuit this. Now we're used to, all of these, I don't like to say their names, but the things that you talk to now that like respond back to you, because if you say their names, then people watching at home can get them things happening, so I'm not going to do that. But the sounds that they make, the ways that they light up. I was working with my teams, and I come up with a script like, I'm stuck under the couch, or I need you to help me, or your coffee is not ready yet. Like, those things are messages. So I write them out in English and then work with the team to figure out, okay, well, what are the lights, or what are the sounds? So in this case, this is a Neato BotVac, a floor cleaning vacuum, and it was a startup. It was during my work at Smart Design, and I led the interaction effort and got to work with a composer around these sounds. So we're starting to go to work, and this is, oh, hello. And that's when it recognizes a person. This is a prototype, obviously, but I'm stuck, I'm trapped. And this is waking up and goodbye. So, and there's a whole suite of them. And it's been fun to see them in people's living rooms. Context is the next ring after expression, and it is one of the biggest challenges in robotics, and what we're going to see as we see more and more interactive products. And what we mean by that is that the object needs to know not only how you're interacting with it in a direct way, but what are all the other circumstances? So what's the temperature in the room? How far away is the person from the object? What's happening in the calendar? What's everybody thinking about? What time of day it is? Those all affect the way that an object should react to us. So this was something that I created in my studio. So sometimes these things that I'm thinking about, I like to create projects that help me to explore what it feels like. In this case, it's a coat rack. So it's made out of wood, and it's carved out so that there are LEDs that can shine through the wood. And I worked with a great team. This is Eric Stefans, and this was when I was at University of Pennsylvania in Philadelphia. And what we created was something that would light up as you were close to it, and it would give you only the information you need, only at the moment you needed it. So as you were going out the door, you would approach it, and it would wake up, and then it would let you know the current temperature, the high, the low, and any conditions, like if it was going to rain. And it's got an umbrella stand. So it allowed me to test out this idea that we need to really avoid having every piece of information, Facebook feed, stock quotes, and just the whatever sliver, because at this time it started becoming clear that it was becoming more and more affordable and accessible to have this Internet of Things. So this is my Internet of Things experiment that really talks about context. The book goes on to talk about interaction, ecosystems, meaning groups of products working together, as well as the ethics of thinking about all of these interactions and the ethics of thinking about having an emotional response to an object. But I'm going to skip ahead because I want to share a whole bunch of things. And the next thing that I wanted to talk about is how I took all of that work that I was doing with Smart Design, and before that, and in my own studio, and then was invited to come and interview for a position at a very historical institution in the United States that's called Cranbrook Academy of Art. And it is a place that is very well known for almost creating modernism in the United States. And the program, and it was the first new program in 40 years. They're very, very focused on traditional creative work. So ceramics, fiber, photography is newish for them even. So this was very, very, very new to have a program that was called 4D and invite different people to come in and talk about what that vision might be. So me having worked on these physical things with electronic behaviors, I felt like I had a super clear idea what I thought it should be, and they thought it should be that too. And what it was really was thinking about interaction. Yes, we've had so much with apps and screens and software, and those things are super valuable. But my premise was that everything we design needs to consider a holistic context, needs to consider where the person is, what they're doing, what the object is, and what the objects do together. So that's the premise of the 4D design program. This is our art museum. We also have a science museum. It's a 300-acre, I don't know what that is in hectares. I launched this program, and then within less than a year we were in a pandemic, but we had lectures outside. We did what we had to do. So there's a lot of experimentation. There's a lot of making. I'll talk a little bit about. So the Cranbrook also has no traditional classes. So what I do is I essentially curate these 2 years, and I bring in different folks to do workshops. So just this year alone, we had someone coming in to do storyboarding for visualizing interactive experiences. We had someone who was doing microphone technology and capturing sounds from our beautiful campus and creating compositions, musical compositions from them. I will do a workshop or two around the things that I'm stronger in, particularly Arduino and working with sensors. We have a projection mapping artist who came in. We've got a workshop, actually the Monday I go back, that's around 3D scanning, and there was another one in there at some point. I know, we had somebody come in and do a workshop. We had Dre LeBray doing AI and video. So that was just a few weeks ago. So the kinds of things we work on are dynamic product behaviors, like this thing that I'm very interested in. How do we abstract sound, light, and motion? Coding, systems visualization, embedded electronics, AR, mixed reality. I'm very into projection mapping onto objects and surfaces rather than having to put on a helmet. Voice control, 3D printing. Oh, I said 3D printing twice. I must really like it. Avatars. But basically, the program is focused on form. Our craft is form, code, and electronics. We all talk about what does this shape mean? Why is it this big? What's the relationship to the body? That's form. Code. We all do at least the basics, understanding, processing, and Arduino quite a bit, and some folks do Raspberry Pi, and electronics. Everybody learns basic soldering. Everybody learns how to use a microcontroller. And those things manifest in light, sound, and movement, some combination of the things. So what I want to show you for the next part are some of the student projects that have come out of the program. And I broke them into some different categories. So in the experimental electronics part, we have these light, sound, and motion. So this is a project by Chen Zuo from my very first cohort. So we've graduated 4 cohorts so far. So this is an exoskeleton that can take some of your body measurements and then express them. So this will actually move and undulate. This is a lamp by Ryan Janina. So he really did a lot of experimentation around 3D printing. So each of those modules is designed by him and 3D printed so that he gets exactly the light quality he likes. And this was installed in our museum show, and it responds to the volume in the room. So the amplitude of the sound will actually change the light. So it gives you a bit of the temperature of the room, so to speak. This is Michael Candy, who came in with a deep interest in robotics, and he's been building these larger scale robots that use fluorescent light tubes and other experiments. This is another project of his where he had seen a video about a little robot that went into the reactor at Fukushima, and he recreated this robot but made it a fictional character that leaves the reactor and goes to the sea. And what I love about this project too is it's also exploring the narrative part of it and those expressive things. So even just this very, very mechanical looking object has these eyelids that close and moves in a certain way. This is another piece that's a timepiece that will actually, it has a weight in the middle of it, that triangular piece, that will allow the entire structure to move. So it becomes a timepiece, and that doubles as a sculpture in the room, and it will actually rotate itself and based on the seconds. This is Jessica Harvey, who's in my current cohort. And she came in with deep passion for carving in wood. So she carves all of these herself. So they're very personal and very expressive. But in my program, she's been learning how to make them reactive. So this one you talk to, and it moves. And then she's got an ear one that she just created. So these are really lovely. Virtuality and digital presence is another thing that we certainly want to explore, the impact of life online. So this is a piece by Vikram Kaladindi, who graduated in our 2022 class, and it's called A Pound of Flesh. So we had a seminar around NFTs, and for those of you who may not be familiar, it is using blockchain to sell artwork. In other words, having artwork that is only distributed digitally, but yet has some limited sense to it, like you only have a certain number of them. So in this case, he sketched out a contract where he would lose a pound. He wanted to lose a little weight. So there would only be 20 of them. And for each one sold, he would have a contract where he lost a pound. And it was actually an animation. And he did not launch it yet, but I loved his playing with the concept. So this is Jerry Lee from our 2021 class, and he had created something. Every year, the students are asked to place a piece in the museum. So they have to think about all the things I asked them to think about, this form, code, and electronics. They also have to think about audience and space. So large walls in the museum. So he created this dynamic emoji, if you will, so that people visiting the exhibition could actually enter what mood they were in. And then this sculpture would represent the mood of the crowd. So there he is working on it. This is another piece by Vikram from 2022, and it's called A God Forsaken. And what he was playing with was this idea of this dialogue that happens in cyberspace. So the writing on the scroll is from video games and video game chat. And he created this system where the pen will automatically, it's on two different motors that move it up and down. And it will actually, it's got a Sharpie in it, and it will write out that dialogue. So it's this continuous scroll, and it's almost playing on this idea of, thinking about technology as this black box that we believe in. And there's a lot to be. We could talk about this for an hour, but I won't. Okay. Social commentary and critical thinking is actually a big part of it. So we literally sit in a room and talk about one of these projects for an hour or more, and that's a big part of the education. This is from Meryl Norlander, who was interested in encouraging dialogue around fluidity of gender identity, and this project took place during the pandemic when I encouraged students to do work outdoors. She had videoed herself floating in a pool. This is actually just rocks. All of our pools and fountains were off during the pandemic, so this was a dry surface, but she projected the pool water onto it. And then in the background had Brian Kovac, who was singing an aria from Carmen, and projected it onto this is our Greek theater on campus. There's Brian. And so, there was also like the fluidity happening behind there, the gender fluidity happening in the performance. This is another piece by Michael Kendi, and in this one, he was looking at a famous experiment by Lauren Carpenter, where the crowd was able to control a game of Pong by deciding if it would be left or right. And he wants to do this in an autonomous vehicle. The goal is a fully life-size autonomous vehicle. So I brought him around to meet with folks in Detroit and find a racetrack, but he prototyped it, a working version, in this smaller RC car. And so these are folks in the crowd. There's Michael with the car, and the car will be driven. The decisions will be made. So this is in order to have folks think about what's commonly called the trolley problem, or who makes the decisions for something like an autonomous vehicle where it's a life or death situation. Materiality is also another big part of what we're doing. There are new materials that are created based on LED surfaces or capacitive touch surfaces, et cetera, et cetera. So some of those so this is another piece by Meryl from our 2022 class, which was a glowing outfit for this skater that was made with folded paper. This is Carla Diana, who is in my current cohort graduating this year, and she's been really interested in replicating the exact conditions of light through a window. So she can program it to be any time of day, to be a sunset, to be a sunrise. And then what's really lovely about this is a common architectural piece in the States, at least in Detroit, and where it's a glass block that we see in our bathrooms, and so she just created this isolated glass block that you can take and pop anywhere, and then suddenly, even if it's 8 p.m. at night like it is here, you can be looking at a fresh sky, and it really feels like you're looking through this portal to the sky. This is Emily Bomarito from our 2022 class. She was exploring soft robotics, so she cast these in silicone and then was applying pneumatics that were controlled with an Arduino to have them change shape. This was Chen Zhuo, another project. He was the first one who did the exoskeleton, and this one he was really fascinated with ferrofluid. I gave him so much credit because I watched this. Sometimes I guide my students and sometimes they take off on their own. And he really wanted to learn how to control ferrofluid, and he did. And so for his show in the museum exhibition, he had what looked like a little sketch of ink, but then the ink would actually move, and it wasn't ink. It was this ferrofluid that has iron particles in a fluid that you can control with a magnet and a motor behind it. This is a piece that I threw in because I love it so much, and it's not from Cranbrook, it's from a previous course. So part of my back and forth industry and academia is I realized that there weren't courses in what I call smart object design. So I created some of them at the institutions I was at. This was the first one, which was a 7-week class. And this was a team, Sam Wanders, Leroy Tellis, and Lucy Knops from 2013. And they really were talking about how much they loved the physicality of books, but yet they love their e-readers. So this is their way of combining the two of them. It's a concept. It is what we call a video prototype, where it's orchestrated. But I'll share it with you because I love it.
Light is a smart desk light that enhances the reading experience for researchers, students, and book lovers. It brings features previously limited to ebooks to all books, however old they may be. Definitions, highlights the spark contextual encyclopedia definitions and other data. Image scanning. Social highlights from other users.
So I love that project. So that's the student work. So now I'm going to switch gears a little bit, and I've stepped aside a bit at diligent robotics. So that's the part of my practice that I've been doing alongside my teaching, and that's opened up some time for me to think about some more projects in my own studio. And coming to Detroit after being someone who grew up in New York and with parents who came from Italy, and I took public transportation everywhere. We didn't have a car growing up. And then I moved to Motown, where everything happens in a car. It felt very isolating. And I felt like I loved everything about this new place that I was in, but I had to say something about or do something about this challenging situation that happens in most cities in the United States. So what I did a couple of years ago is I started also trying to navigate the world of arts grants in the US and applied for a grant from an organization called the Knight Foundation. And the grant was based on some reading that I had been doing. These are illustrations from a book called Ghost Road by Anthony M. Townsend. The illustrations are by a colleague of mine who's actually in Detroit named Brian Boyer, that looks at lots of different configurations. And me coming from the robotics world realized that a lot of my friends in the field were working on autonomous vehicles. And in addition to that, folks that were in urban planning were starting to have new ideas about what transportation could be. And a lot of those ideas involved people not having to have private cars and have a shared, combine the sharing economy, electrification, and networked vehicles, so that if you can imagine a car that can be by itself but then can become a train if they all go up a very popular route and then can break off. So what happens in this book as well as other books, there's different terms for it. I call it software rails. Detroit used to have one of the best public transportation systems in the 30s and 40s, and now there's something, but it's very limited. And so I feel like this is really an inflection point when the US transportation situation can be different because of autonomy. If we leave it up to the automotive companies, they'll sell us more cars that have autonomous features. But what if we thought about it differently and said, hey, why do I need to have a car? So I thought about a project that would fill the walls of a space, let's say this space, with animations of what it might feel like. Because I realized that rather than taking a very literal approach, it would be better to take a really abstract approach that got people having conversations rather than saying this is how it's going to be. Say, what if? And in order to do this, I applied for this grant from the Knight Foundation. I contacted my friend Motomichi Nakamura, who does a lot of projection mapping projects, and I approached a place called Michigan Central, which is this old train station in Detroit, which just reopened last year after decades of being completely closed and in disrepair. And it's reopened, and next to this train station, and it's purchased by Ford, it's a Ford Tech Center, so there's still a lot of things. So next to it is a place that's this long building that is, it used to be the book depository building. It's part of Michigan Central now, so it's a whole complex with the train station. And my project is called Mobility Town. So instead of Motown, what if we could be Mobility Town? And instead of the place that's known for making all the cars, what if we're the place that's known for making transportation businesses? And think of it differently. And so New Lab is also a place that I put this slide in because I was thinking of hosq and about organizations and creative communities, and it's a place where startups can rent space. So it's full of startups with drones and ATVs and autonomous vehicles and bus software, and so it's pretty exciting place. And so Motomichi and I have been working for over a year and a half. So I'm really in the thick of this project right now. And it's called Mobility Town. It's a 5-part experience that happens on the interior spaces. So this is the front desk, for example. When you come in, you have a little story about these characters, and they come from the airport. So just coming to Detroit from out of town, your friends can jump on a car. And then there's another experience where you'll sit on a bench. They'll actually, I'm going to get in front of the projection. You'll actually be on a bench with these characters here, and they'll jump in this train, and they'll go off. So you're sitting on the bench will be the act that triggers. So I'm really working hard on, I'm always kind of a tinkerer. So I've been talking to Motomichi for years about doing interactive projection mapping. And now this is the project where I get to do that. So we've got this interactive bench. We've got this, New Lab has an amazing tech facility with a robot arm that's behind this window. So this will be part of the factory where Detroit's still working, and it's working on these new ideas. And you'll be able to turn a wheel, and as you turn the wheel, the projection moves around. This is the cafe wall. So it's got this cafe that is actually got these structures. So one of the things that I love about projection mapping is that you can take the architecture that exists in a space and you can design around it. So because this space already has these squares, we came up with this little apartment building. So all the characters live in this apartment building, and then there's a train that comes in the basement. So the train comes, and then the characters get in. And while they're waiting for the train, and this is one I'm in the middle of, you wave at them and they wave back, or you give them a thumbs up or thumbs down. So I'm really interested in this idea of interacting with the projection. There's also going to be an AR experience. I'm working with a developer who is working in Unity to create the AR experience. All right. Sound experiences. Okay. All right. So that I threw in a last part last night, and it's pretty raw. It's like my raw things that I play with. And do you guys want to see it? Yeah. All right. Okay. The first things are not so raw. This is a project that I did in 2002. It was a website. It was called Repercussion. And I wanted people to have the feeling of what it feels like to compose music. And I broke music into these like architectural structures. So this is what a rhythm looks like. And you could pull the rhythm apart, or you could squeeze it together. You have a chord, you have melody. The melody has these steps that you can pull up. So this kind of is the foundation for a lot of the sound-based work that I like to do, because this really what started putting me on stage, because I won some awards with this, and because it was on the web, people all over the world were saying, we want to do a project, let's collaborate, blah, blah, blah. And, it's also doesn't really need language, so it was super international and super fun. So I threw this in here to show. I don't usually put this one in because it's a website, but it was a big project for me. This next one, it was a collaboration from 2014. I did a residency at School of Visual Arts in their lab that's called the Visible Futures Lab, and as part of the residency, we had something where you get 7 weeks and you do a project, but we did the two of us together. Anyway, so Emily's become a really good friend of mine. She focuses a lot on sense experiences. At this time, she was doing a lot of work with food. I was, of course, putting sensors in everything I could find around me. And so together with a composer named Aaron Dyer, we created this performance that's called the Lickestra. So I have a sensor, so anybody can put their ice cream in the cone, and it becomes the music. So, and then, yeah. We had a lot of fun with this one. We got invited to do it. It's huge. Wired called us. American's Got Talent TV show wanted us to go. Emily said yes. I was like, no, And we did a performance. We got an ice cream company to donate the ice cream. We did a performance in a gallery in New York where we got volunteers. So, but I just loved that I could make the ice cream the sensor, and it didn't have to have any electronics in it because I was using capacitive sensing for the geeks in the room. Okay, this one's from this summer. I have this idea about gesture and sound, and it looks a little like this to start. just a little off. And this is where I just like let it all go. Yeah, my timing's off, my dancing's what it is, but that's what I do think. This is a project that I did with composer friend, Scooby Leposki, the same guy who came in and did the workshop. That's what I try to do. I do a lot of things, but I try to make them all come together through community. And we put sensors. This is on the Cranbrook campus. So we have sensors that were in this bridge. We have a Japanese garden, and I put sensors in foam inside the slats of the bridge. And he had actually also connected plants to sensors and composed the music. So his part was the plants and the overall composition, and then my part was adding the visitors' input. So in this case, I put light sensors, photocells, so that your shadow would, oh, here, I have another one. So that your shadow would, so this is all percussion. So as you move by the rocks, they all trigger. It's a little more subtle. Oh, this is from a few weeks ago. So I'm super interested in, again, getting people to feel what it's like to compose music. And this was from a gallery show that my students and I were invited to put work in a gallery show. And I had this idea, oh yeah, they're okay, let's skip that one. I had this idea that it would be, and then this is people at the gallery, that it would be great to have a dinner party and have everyone at the party have this cup. And your cup would be what would be part of the composition. So, there it is. So as you put your cup on, so it's also capacitive. I'm also trying to master capacitive touch, which from a tech point of view has a lot of challenges. So, but as you touch the cup, because there's a capacitive sensor underneath, it makes the music happen. And so here, no, let's go away. Oh, and this is for the gesture work that I'm doing on the Mobility Town project. I'm exploring gesture and Python and MIDI. So there you have it. That's the raw stuff. Thanks for sitting by that with me. And thanks for having me.
Thank you so much for lots of exciting examples that you showed and shared and that you're developing. I don't know how familiar you are with the Armenian scene of IT and creativity, but my question is about that, and whether or not you're familiar or not, I think you'll have an advice to share in general. You mentioned so many schools and universities you work with and collaborate with. My question is how important is to have this sufficient academic scene in order to have such productive marriage of creativity and science? Does it take an academic scene, or it can be just bits and pieces here and there working together? Because here we have a more or less thriving IT community, which is involved mainly in, providing services, in healthcare, in like the Moxie robot. There's some Armenian brains behind it, but they do not really marry the creative scene so much. So how important is it to have the academic scene? And if you're familiar, do you see institutions that could could grow and develop that kind of departments here in the sense of academic? Thank you.
Yeah, so that's a great question. I would say on the side that even education is in the midst of disruption, and the traditional structures of education are in question. Like in the U.S., there are folks who, companies that now want to hire based on skills and not necessarily your degree, et cetera. That's a big, long conversation. I certainly think that someone who's driven with a project can pursue it certainly outside of this academic context. And I'm going to repeat myself a little bit, but I think that ideas will thrive with community. So things like meetups and regular meetings of people, and making sure those people, bringing artists into the fold, bringing philosophers into the fold, bringing writers into the fold, and part of those conversations, I think is going to be really critical for our future in this hybrid creative technology world. And certainly, the beauty of academic institutions, and what I've always loved, and whether or not I in the future am teaching or not, I will look to academic institutions because they host lectures like this, or they host events. So I do think it's a good nexus for community, but it doesn't necessarily mean that if you're not committed to this full 5 years, 2 years, whatever it is, that you're outside, right? I think that universities provide community, they bring experts to it, and I think that someone who's really passionate can take advantage of that in either way. And I've been loving my time in Armenia, but I have to admit I'm not familiar enough to answer the second part of your question.
Thanks again for the cool presentation, and
thanks for coming.
They were both fun and insightful and offered creative solutions, and that's very admirable. One question I had was about Mobility Town. I think I might have missed something. I didn't quite understand exactly what it does besides the projections and everything. Just what exactly is Mobility Town, if you can concisely.
Thanks for asking, because I put a lot of things in the presentation, but also realized that it means that I don't talk about every aspect of it. And I was worried that some of the story might be missed. So the idea behind the project is to illustrate a Detroit community, albeit with characters made of circles and squares and triangles, but this community of characters running along the walls that have public transportation. And the public transportation would be enabled by what I'm calling software rails. So vehicles that can be smaller and go to outside towns or link up together along main thoroughfares and become trains where infrastructure doesn't exist. So this is an idea that comes from my research into the many books that are out there around future technology, the intersection of future technology and urban planning. And there's a program at University of Michigan that's called the Urban Technology Program, as well as other architecture programs that are exploring these ideas. And so I want the projections to be an illustration of some aspect of those ideas. And the crux of it is not to talk about the technology, but to get people talking about, wow, wouldn't it be great? And there's other aspects of it. Like there's one, in the VR aspect, you're actually able to call a vehicle, this cartoon vehicle, to the spot that you're at. And I'm trying to illustrate what everyday life might be like so that people in Detroit can talk to each other and say, wow, do you think this would be possible? And I'm bringing in experts, government, transportation experts, in a panel discussion at the opening of the exhibition, so that we're talking about real ideas, but they're illustrated in this playful way that just gives you the feeling of it without getting into the weeds of how it might work.
I really like the presentation and all of these projects because they're really cool and fascinating. And it would be great if we have in some year something like that in Armenia too. So as a designer, I am exploring the user cases of implementation, this kind of things in cultural institutions. And I wanted to ask, had you ever seen some correlations between using these technologies and getting more visitors or engagement in this type of institutions? Because there are some problematic places in Armenia, museums which have no visitors, and how effective it can be in terms of driving more visitors and etc.
I think anything that makes a better user experience is going to drive more visitors to an institution. And the challenging thing with technology, especially when you work with it as a designer, is it can be very seductive. And maybe it's not the best way to interact with something. Like there was a museum in the States that had an elaborate way of capturing the things you saw and collecting them, and they wound up scrapping the program because it was too elaborate. I can tell you privately more about which museum it was and what it was. The bottom line is design, really, and good design should bring, and marketing, frankly. I think that I think people find it fun and playful. Like in the gallery exhibition where I did the musical tablecloth, all the other pieces too were interactive in some way, and people were really engaged and alive. And we had a closing dialogue discussion that the gallery owner said was much more animated than in the past because people, I think, felt more intimate with the work.
I'm part of this. My question is, I'm from Russian Federation and I have high education in St. Petersburg as engineer in the branch of the high electricity. And my mother country, Russian Federation, doesn't need my profession because this branch needs very much financial investigation. And my question is, if, for example, one country like Armenia or Russia, or one branch, or one company, or one school needs these technologies, how much money must we have to use these technologies? Big money, or middle money, or very small money?
This is a great question, and it was. What's been particularly exciting about the opportunity to create the 4D design, which is now called interaction design program at Cranbrook, because I've been involved with these physical computing programs for many years, and I've watched the price of things come down significantly, and the accessibility to be able to use things, and more and more open source software, like things like the Linux and the Raspberry Pi and Arduino. The Arduino community is so enormous and so much about sharing. And I know that 20 years ago, to do the kinds of things we would do, some of these kinds of experiences would be a $50,000 project that you can now accomplish for $200, and you can ask the students to, if it's something they want to do that you don't even have. But I tried to equip our lab, but I was able to set up a lab. We did have to invest some in 3D printers and some equipment, but wow, is it so much more affordable? And I think communities even outside of academia can have maker spaces now that allow folks to do this kind of stuff. So I think it's remarkable what's happened in the last 15 years. And a lot of it has to do with open source And yeah, and it makes it just, and right, and the tools and the software, which make it so much more accessible for people who aren't master coders to really accomplish something quickly. Yeah, it's a cool time to be doing this stuff. I feel like, a lot of people said, oh, the program, is it kind of late? And I thought, no, it's the right time, because earlier on, a lot of the other programs that were similar were purely focused on software and apps, a lot of the other interaction programs in the US. So I was able to bring this tangible interaction focus to it.
First off, thank you very much. Good stuff. Like, it's awesome. Like, the primary thought that stood in my head was that, wow, she gets it. Because there's this thing that I've noticed, like, I constantly interact with the art community, with the design community, with the tech community. And the thing that I've noticed a lot is that art people are way too focused on art and don't care about design and tech as much, like, sort of look down on it. And from what I saw from what you showed us and the ideas that you shared, was that you really pay what's due to each of those. So it was really awesome. Really, the thought that didn't leave my mind was that, wow, she gets it. Like, you just kept really combining them as they should be combined. And I actually, if I were to ask and share everything that I have in mind right now, would be here all night. So I'll just try to ask the first question that popped in my mind chronologically.
Okay.
On the first place. Yeah, definitely. Thank you. How did you approach the issue of the uncanny valley when designing Moxie? Like, I'd like to hear your thought process. Why? Because recently, just for some context, recently I was engaged in Cybertech Sprint, organized by Tumo Labs, and it was a sort of, to simplify it, it was just about creating a cybersecurity product. And we decided to go with some add-on that would sort of warn people against social engineering type of attacks, I'd say, cyber attacks. But it would do it in an intrusive way. Like, the usual protection is like, this is a bad link, don't click it, and all that stuff. And the initial reaction of the person is that, like, who are you to tell me what to do? And really, I wanted to factor in the human interaction thing, like make it more likable and combat the uncanny valley effect so that people feel more affection and thus more trust towards the software, towards the product. Like, I wanted it to be armed with like really human phrases, I suppose, like things you'd expect to hear from a human, but not just ex-human, like human with a personality, some type of personality, like the exact personality. I don't know if this matters or not right now. The exact personality that we wanted to mimic was that of a reserved, intelligent, polite person. And this is why I'd like to learn about your thought process when addressing this issue, when really addressing, like, how did you combat the uncanny valley effect when designing the robot?
First of all, again, it's a team effort, and a lot of why I loved working with the Socially Intelligent Machines Lab is that they also came to the project with some deep research around, let's say, how many degrees of freedom the robot was going to have, whether or not it was going to have eyes. And then I brought the actual size and shape, and we had some design constraints. And I think, again, I'm going to advocate for design. Like, a lot of it comes back to design and process and really being explicit about what the design goals are. So we knew that we wanted to avoid the uncanny valley. And in order to do that, we set this kind of continuum where you have a machine on one side and you have this humanoid on the other side. And so we really targeted to be in the middle and showed people sketches and had scaled down prototypes and 3D printed those and tried to get people's responses to, does it feel like a robot? Does it feel like a machine? And we tried to be, machine or appliance is what we, so we really tried to ride that line. And then the other guidance that I had from the researchers was that particular, the Simon project was, so Moxie's a different story. But the Simon project is the, and it really had fingers and blinking. And, I had gotten this guidance that it should look young because it was a learning robot. And so you didn't want this impression that people would have. Like right now, there's a few AI robots out there at science fairs and things, and they're very, very humanoid. And you ask them a question, and they know the universe in their in their responses. And we specifically wanted this entity because a lot of that robot's goal was to be a learning robot, and so we wanted it to look like it knew nothing and just be able to learn these simple tasks. And we knew it was going to be in the realm of simple tasks. So I studied animators, and I studied illustrators, and I studied the proportions of literally toddler proportion. How big should the eyes be in respect to the head? How big should the head be in respect to the body? So those things were really super deliberate. So I'm glad that you asked about that. And then the MOXIE project, I really wanted, and the founders of the company to not have it be humanoid, but yet, and I actually wanted to push back a bit on, because it was the hospital, and did we need it to be extra serious? And then our research came back, and with people really loving having this little bit of whimsy, so, and because the social aspect was so core to the company's value, we needed a head, we needed eyes. We decided that those were some limited constraints.
Thank you very much, Carla, for your presentations and for gathering us. My question is, a lot of people have just maybe thought an idea to create something, and how to make this idea real. Maybe do you remember the beginning of your track and give recommendations or some inspiration for people who want land their ideas in the real projects or real things that will be very useful for the world, not only for the country maybe. And did you understand my question?
Yeah, no, I totally understand it. And I think it's a pretty challenging idea. So I did it the long way, which was to go to study. Years. I studied a lot. I studied mechanical engineering actually first, and then I went back to school after working 7 years for design, but I didn't have all the art background, so I did a year of art, and then I did an extra year at the end. So anyway, but obviously I like being in school. I went the long way, right? But someone who doesn't necessarily have that background, I think, can also pursue an idea. And I think that a collaboration with a designer. So I've seen there's a firm, one of my former students founded a firm that's called Tomorrow Lab that's in New York that gets approached by startups with ideas, and they develop these electromechanical systems. But as an individual, approaching a company is, you're going to get a quote back. It's going to be very expensive. And, if you can find a designer and an engineer, depending on the project, that are also excited about if you can find partners that have the knowledge and, figure out, you do your homework to prove out the value, understand the market, understand the viability, a basic, maybe first just conversations with a friend, and then get partners who can be part of the project. So that's the metronome project, the drummer project that I showed, the click brick, that really started with somebody who didn't have any design or engineering background, with Conrad. And he had approached Ted Booth, who was a former colleague of mine, and he said, I can help in some of this, but Carla really loves being creative with the electronics, and I knew that Mike could do some of the industrial design, and we all did that work together without any cost. Like we brought our own skills to it. So if you can find those partners that have the skills that fill in the blanks, and then together we applied for a patent and we were awarded a patent, and then so they're actually, and then we were business partners, and then I stepped out of the, I mean, there's lots that happens after that, but it's going to trade shows now. Like it's very hard to get a product to market, but it's doable. And I think finding a designer, an engineer, and people have to be into it. If people are into it, they'll put their time in, they'll meet you after work, you know.